Okay, sige. So now we are going to focus on the ADT linked list, no? Okay, so actually when we talk about linked list, guys, so you can just have I mean linked list is actually a built-in ADT in Java, okay? Along with vector, array list, stack, and queues. So we have this what we call na uh, general list and restricted list. Now, when we talk about general list, these are lists that has no restrictions at all, where you can add data anywhere. Add in the middle, add at first, add at last. You can remove at first, you can remove at last, or you can even remove in the middle. So that's the general list. Now, when you talk about restricted list, this one example of that are actually stack and queues, where you can only add at a specific location. Particularly when you talk about stack, the adding and removing will only happen at the top. Tama ba? No? Sa queue naman, adding will happen in at the front, at the rear, and then yung removal niya is it will happen at the front. So kaya FIFO ang tawag sa kanya. FIFO, no? First in, first out. Now sa linked list naman, this is an example of general list. Kasama niya sina vector at saka si array list. So allow me to use a PowerPoint para mas mapakita ko sa inyo yung what you call this one before we'll have our coding. So, ayan, I have here the two categories of list. We have general list and restricted list. When we say general list, any insertion and deletion can be done anywhere, and there are no specific restrictions on the operations. This just like sa stack and sa queue na ginawa natin so far or previously. So, yeah, when we talk about ADT, most likely, especially in the linear list, the operations of this list algorithms comes in a they have actually similar operations: insertion, deletion. In stack we have push, in queue we have in queue, and deletion is in stack it is pop. Now in queue is the queue. Now in here in vector, array list, linked list, most likely we use remove. Okay. So now, when we talk about retrieval as the operation, this is used to fetch something from our list, meaning we're going to get a value from our list, and then the traversal is it's going to visit all the nodes, all the item in that particular list, and this requires a loop, no, algorithm, a loop process. So most definitely, the one thing that I want you guys to understand is that when we talk about linked list is actually consists of two has or parang nodes which consist of two elements. So ano yung elements ng linked list? So may tinatawag tayong node. A node is it's actually the one that you will create out of implementing linked list. And this node will have two elements. And these elements are called the data or the value. So this data and value is ito yung data or input that we are going to give to or to store to our linked list. Either number sila, either whole number or with decimal, or even character or string. Okay? Then, yung pointer naman, I don't know guys if you've heard of pointer in C++ or C. So pointer holds the address that is going to connect the list of the parang nodes in our linked list. So yun yung concepts that you will need to understand. So again, it consists of a node where naa siya dalawang parts. We have data or value and then the pointer that points to the next element or to the next link. So ano yung data? So as I've told you, ito yung input that we probably ask from the user, and then This is what we are going to maintain in our list. Then yung link, it is going to connect or create relationship with our list or our nodes within the list. So ito yung logical representation ng linked list. So every list has a head. This one right here. No? So it has a head. When a head points to null, it follows that the list is actually empty. Okay? So every time mag-create tayo ng list, null pa talaga yung head. The moment na there will be a new node added, it will have now the address. I'm gonna show you ano yung mga addresses na i-assign ni compiler or Java compiler to our nodes. So, ito sila, data link, data link, data link are what we call nodes. Okay, do you follow? These are called nodes and each node consists of data and link. So, yung data are the value, okay? Yung link are the addresses that connects every node. So most definitely, itong si head, ang address niya is pointing to the next node which is ito, data and link. So yung address ng node na ito, ng first node, will be the address that is held by the head. And the next node follows after it will be the address that is held by this node right here. And so on and so forth. So that is the representation of linked list. However, since linked list is a general list, therefore there are no restrictions in adding data or value to it. So you can insert in the middle, you can insert in the beginning or at the beginning, and you can even insert at the last part or last list. So that is now what we are going to do. Okay, so let's now go to our program. So again, as I've told you, ang linked list may built-in ADT na yan sa Java. So that is called linked list. Other people would read it linked list. So it's up to you. Okay. So yeah, linked list. And don't mind this one. This would mean na ano yung data type of information that you will have to maintain, whether it's integer or if it's double or if it's string. If you guys want to maintain whatever type of data. But if this one will be removed, this would mean that you can maintain any data or inputs. Okay, just the usual linked list, array list and vector. Linked list din kasi by the virtue of inheritance and encapsulation na OOP principles, they are actually family. Magkapamilya lang yan sila. Array list, vector, linked list. In fact, si linked list may add din yan siya. Then it can add any data you want, so it's the same idea sa vector and array list. You can add as much as data as you can. However, the linked list, if you try to check, guys, meron siyang mga operations like add first. Okay, if you're going to click add first, let's say 100, this will be added or inserted at the beginning, not replacing, but the numbers 4, 6, and 7 will cascade, and 100 will be inserted at the beginning. Okay, so that is the capability of a linked list where array list and vector doesn't have any. Okay, so now meron din tayong tinatawag na add at last. So if you want to add the data at last, you can also add. So that's basically making linked list as the generic or general list wherein walang restriction. Okay, so if you guys want to display them, you just have to call the object right away. Guys getting it? Are you guys following? So, take note, tingnan nyo, si 100, andyan na, and then, it's 4, 6, and 7 are cascading para ma-accommodate niya si 100, and 69 will be since add at last siya. So, whenever gusto ka mag-add ng add at first, you just have to call add first. So, this is something na wala kay vector and kay array list. Okay? That's one thing for sure na dapat ma-remember nyo with linked list. So si linked list, wala meron siyang remove, but in the same way happen na meron siyang add first, meron din siyang remove first. Okay? So si LL meron ding remove last. Okay, do you guys follow? Hello? Are you guys following? Can't seem to see people in the online. Are you guys following? Okay, thank you. So if you guys have questions, please ano lang ha. Okay, very good. Okay. So now, if this is what data struct is all about, then data struct could have been simpler. No? So yes, simple lang man si data structure. If ang course nimo is information systems or information management or IT, but in the case na ComSci ka, hindi na, or EMC. Wait for a while. Some microsystems or else wala other sige. Balik tayo. Anyway, I haven't started yet. This is just a opening remarks. No. Again, everyone, data structure could have been simpler kung ganito lang siya, no? Implementation of linked list. But it's not like that. It's not the case. It's not always the case like that, no? So, data structure is all about simulating a certain algorithm or ADT. Okay? So it's like, as I've said, if you want to become a car mechanic, you would have, it's not enough for you to only know how to drive. People, no? Hindi siya pwede na kabalo lang ka mag-drive sa car. You'll have to get inside. You'll have to dig deeper. You'll have to remove all the parts and study them. No? So in order for you to know how to fix the car. So in the same way happen, ito yung gagawin natin. We don't settle on using only built-in list algorithm. So we are actually going to simulate. So since you are programmers in the making, no, you will become programmers eventually. You'll have to know how to implement this ADT. What if? Now imagine these things are not created. So at least you will experience how hard it would be if you live during that time. No? So, yun yung idea ng data structures and algorithm for ComSci specifically and for EMC. But since majority sa atin dito is mga ComSci, so we'll need to simulate and create our ADT from scratch, no, na linked list. So, what we're going to do is we're going to create a class and let's name it as a node. Okay, can you guys do it? Node, okay? So this is what we're going to simulate the linked list, no? Whatever capability of linked list is yun din gagawin natin in our node. So, i-reverse engineer natin si linked list, i-simulate natin yung capability ni linked list as an ADT and we call it node. Okay? So, let's get started. Number one, first is we'll have to know what type of data you're gonna be maintaining in your node. So let's say we want to manipulate muna numbers. But in the case na ayaw nyo ng numbers lang, ayaw nyo ng letters lang or characters lang, you can have it as object. But this time, para hindi masyadong like difficult to understand, we would focus muna on the integer na value. So let's have here as, let's say, data, which is the same sa ginagamit natin for stack and queue. Okay? So this time, di ba I've told you, node consists of two components or two elements. Yung data and at the same time yung node and yung link or yung address. So we will now have here the next. Okay? So ito yung node that connects the list or all of our nodes in the list and yung head to determine whether yung saan yung head ng list natin. So saan yung pinakauna? So yung head means it is the first node. Okay? So we are going to define it or declare it with the node class. Okay? So now let's create a creator. Okay? So basically, gagawa lang tayo ng constructor for that. Okay? So we're actually going to make the head is equal to next is equal to null. So we're going to set up everything to be null. Okay? This time around, importante na we have declared our head and our next to be null. Kasi this would make our list this is an indicator that our list is actually null or pointing to nothing or pointing to null. And we would know that if it's empty or it is the last element or it's the last node in our list. Okay? So you can have any, you can overload your constructor, but this time it's enough for now na ito lang muna. Okay? So let's have now the first operation, which is empty. So by the way, I forgot to tell you, pag mag-create tayo ng node, this time, hindi na siya the usual na array has a fixed value. No? So what do you mean by fixed value? So kung ano yung size ng array, yun yung parang specify mo, yun din yung value that yun yung value that the array can store. No, yun lang yung value na mas to store niya. So this time the linked list doesn't have that parang hindi na siya ganyan. Yung behavior niya is it's dynamic, meaning it can store, you can store as much as data as you want. Pwedeng merong capacity, but I would call it like size, yeah, rather than capacity. So parang wala nang max capacity, or if you mean like that, Nara, no? So yeah, it's basically hindi na siya mapupuno kasi we're going to use the RAM capability, yung memory natin. Okay, we're going to actually deal with RAM. So is empty Ayan. And the only way for us to know that is when the head is equal to actually null, that means a list, okay? The list is empty. Yeah, basically, if the head points to nothing or null, it means our list is empty. Okay, so that's the first operation. Okay, so we have operations of LM. Okay, so yeah, return boolean. This one doesn't necessarily na i-follow nyo. It's okay pag wala, okay ra wala in no? So let's have another operation. So let's simulate yung kanina na add first, no? Ito, add first. Okay? So public void add first. So we have int value. So we're now going to create our own from scratch based on what we have understood in the linked list. But this time, we even though we don't know what's inside of the add first, add last, but since we are a programmer, we're going to do it on our own. No, the way we think it is, or the way we think it is written. So yeah, basically we're actually simulating it. So now you can have here if possible, if the list is actually empty, then probably we're going to add that node at the beginning. Okay? So basically, ite-test lang niya, evaluate lang whether the head is equal to null. So, lagyan natin dito. This is end of add first. So, para mas organize yung codes natin and easy to read. So, end of if. Yan. Are you guys following? Gitigan and Co. Okay, very good. So now, let's have here a declaration of node. So let's say new node. So mag-create tayo ng new node in order for us to create a first node in our list. Okay? So whenever it is empty, we're going to get the data. So since dalawa yung component or elements ng node, so the first element is the data, and where do we get it? Dito sa mismong argument or parameter ng add first. So we are going to assign value to data. So this is the first. This is now the first element. Now, then the another element of the node is the next. Ito yung kanina. Ito. Okay. What's the this points to null. So we are assuming that whenever mag-create tayo ng isang node, the next node after that will point to null or nothing. And that means that's the end of the node, or that's the end of the list. So it's basically parang array lang din siya. Kaya lang, ang array only stores value, actual value. And you can access it using index. Okay? Pero si what you call this one, si vector array list, and particularly si linked list, hindi natin ma-access yung data using index. Okay, walang ganon Mars, no? Walang ganon sa linked list. Basically kasi we are dealing with real world na address, no? Yung real addresses talaga ng RAM na ibibigay ng RAM natin to Java, no? I-assign niya. Later on makikita nyo ano yung mga addresses that we are going to use. Okay? And then this time we will make that, since bago siya, since empty ang yung node natin, we are going to assign that node as our head. So, ang nangyayari dito is whenever you pass value to your node, let's say 5, if the node is empty, or if the list is actually empty because the head is null, what happens here is that the 5 will be assigned as the first element of the node, making it na kung ito yung node mo, you have here the 5. And then ito yung next mo. And this points to null. Tapos, yung head mo is andito siya. That points to the next node. Okay? Gets, class? So, ito yung nangyayari that your node now becomes the head. So, yung head mo, basically, ito na siya. Siya na yung head. Okay? So, that is it for adding first a node. If ever na hindi siya empty, like if there are already existing node in that particular list, syempre, gagawa tayo ng isang else condition. No? Else block in that if. So in case, yeah, may 5 na. Let's say, since 5, mayroon ng 5 na nag-i-exist as a node. So dito yon magfo-fall sa else block. So ano yung gagawin ni else block? So yung gagawin ni else block would be getting also the data, which is true value, and then yung node mo na dot next will be will now becomes your, so since this is add first, yung gagawin ng node natin will be i-assign niya yung new node as our head rather than it will be added at the 5 dito sa last. So yung if let's say nag-add ka ng 7, okay? So dito siya mag-false, then pupunta siya sa else, then 7 will be added as the first element of that node, which is data, and then this will become your head. So ang mangyayari is si head points to 7, which has next as the first, ito yung first node mo, which points to 5, and then yung next that points to actually null. So yan yung nangyayari internally sa node mo, no? Sa list. So you have now the 7 na node, ito. You have now the 5 na node. So ang nangyayari is that yung address ng head is what this node is actually holding or baliktad. Parang itong node na ito is yung address na ina-assign nito is from head, and then yung address ng 5 will be next. And syempre, since this null is an indicator, ito yung ginawa natin dito, it's an indicator na end of the list na siya, therefore it points to nothing. It points to null. Okay? So to sum up, or para to conclude rather, so yung gagawin natin for this one is so yung head natin will now become a new node. Okay? So mahimo na siyang what we call this one, mahimo na siyang head. So just like what it is, what I have depicted here, no? So yung 7 now becomes the head instead of 5. Okay? So do you guys have questions? Wala pa? Okay, sige. Okay, so let's now proceed with paano natin malalaman na successfully inserted yung data. So let's have here another operation which is called traverse. So traverse is a process of visiting all nodes in the list. So it's a process of visiting all nodes in the list. So now, Pwede tayong whenever yung empty yung list natin, we can have here is empty. So we can return from here na let's say list is empty. Else, otherwise, magtra-traverse tayo. So end of traverse. End of if. So kulang pala po ng terminator. So the traversal process is the traverse operation in linked list is vital kasi this is our way to print all the data kasi hindi na natin siya ma-print using index. Wala nang I is equal to 0 until the length of the linked list. But this time, we are going to assign a node na we can make this this node as our head. So mag-a-assume ta, so this would assume that the link as a head. Kasi we cannot afford na si head yung pupunta at siya yung mag-traverse sa list natin. So instead, we are going to only assign o ikaw yung link as a head and ikaw yung mag-traverse rather than si head yung mag-traverse all throughout sa list. Do you follow? Okay. So this is what we are going to use now para hindi mawala si head kung ano kailangan natin mga assign ng isang node to do that. Okay, so while link is not equal to null, so dito yung sinasabi ko kanina na it's really vital na meron tayong null. Okay, sa list kasi that is an indicator na in end of the list ni whenever may traversal tayo para mag-stop siya to doing the loop or iteration. Okay, so what we will do in the every time mag-visit, no, mag-traverse sa list. So gagawa tayo ng isang third-party variable here and we're going to assign the link every data na mavi-visit niya. And so ito yun, no? Concatenates every state datum or value na lang to hold concatenates every value to hold value visited to hold variable. Basta to hold na variable. Okay? And then ito yung mag-a-update na saan na siya. Parang this is our increment na part. So link is equal to link dot next. So this is the update value. So it's like increment. Okay? It's like it moves forward. So ang link natin that it moves forward, next, and next. Okay? So now, we can then return hold. So return hold right here. Yan. Are you guys done? My friend Ko, are you done typing? Gitigan? Not yet. Sino nga na iwan dito? Si Ko, Gitigan, Perosio, no? Perosio, and si Jimenez. Sifra. Okay. So are you guys done typing? Okay. So let's now go to test LL. So, let's remove the linked list. Siyempre, mag-error yan, no? And we will replace this to node. Okay? Siyempre, let's assume na hindi natin kilala si linked list. Ang kilala lang natin ngayon is the node, ADT node that we have created. So, walang add, but rather merong add first. Wala ding remove first, wala ding remove last as of the moment. Now, we can call traverse. And so, we just have simulated the traverse, no? So, sabihin natin 5, 7, and let's say 10. Yan. So, add first, add first. So, when we run this one, if you can see, 10, 7, and 5 are now stored to our list, to our node, as 10, 5, 7. Kasi nga, si 5 is the data inserted at first. Pagdating dito, since 7 is added as first, so meaning magkakascade si 5 next to it, and then pagdating na naman dito, 10, 7, and 5. So, andito yung head na part natin. Tapos dito yung next na it points to null. Okay? So, yan yung nangyayari. Now, later on, I'm going to show to you saan na yung isang element ng node. Diba? I've told you that the node has two elements. Sabi ko kanina, yung isa, data, and then yung isa is the link, or shall we say, next na node. So either, if I say pointer, if I say link, pareha lang yan sila. If I say link, if I say next, if I say pointer, they are all the same. So if I say link, it refers that it is it refers to as an address. Yan yung klaro ba? When I say pointer, when I say link, when I say next, that is we will all consider all of it as an address. Okay? So ano yung mga address? So ito yung titingnan natin. Ano yung mga address na ibibigay later on ng node natin? So how do we know na may ganyan na value si node? So punta tayo sa node and gagawa tayo ng isang hold, okay, plus equals, and then we'll have here, let's say, link.data, and wait for a while. So assume natin na ito yung node, okay, and then next after that is the link.next. So ito yung pointer, no, yung address. Okay, and then this points to another. So now let's remove this hold here. Not remove, but let's take that one out by putting a comment character or delimiter before it. So now, makikita natin later that we have two elements being concatenated in our hold. Makikita natin that we have the data and at the same time, the pointer or the address of that particular node. Okay? So dito, i-change din natin na ito yung head and it points to okay. So if you guys will run your program, you will see something na characters na makikita nyo na nakalagay at 7A308DB1 at node 7440E4641. So ito na yung sinasabi ko na addresses or pointers that is assigned by the Java compiler using our RAM doon sa list na ginawa natin. So it's an actual pointer, it's an actual address, ha? Galing yan sa RAM. Ang actual address lang natin kasi ni node. The same ba yung output natin? Wala pa print ko ito. Ay, ako po sa gawin. So, 5, 7. Sana. Wala kang customers. Parin mo yung customer. Napakagaling ka. Yes, ko, ganyan. My friend, what happened to your eyes? Just now. So, at first mo, yung at first mo kasi malaki ang table. Yung but it's only one. sa kanya, yes, no. Kaya, dahil ang mananaw sa So, yeah, basically that's the yung first part pa lang ng node, no? Okay. So I'm back, guys. So most of their work does not work, pero okay na. We were already able to fix it actually. So, allow me to explain the things na nangyayari ngayon is that so whenever ito yung nakita nyo dito at first ito, this is the head address. Okay? So ito yung head address kasi kung titingnan natin yung node na traverse, we have the head there. So yung is to store ng head natin is the address. Okay? So ito yon. So the since our head is not null, therefore may mga it's not empty, therefore may mga list siya, or may mga nodes siya uh, pointing to it. So may mga nodes siya na to store. Therefore, meron tayong mga ganito. So this one right here as an address, ito yung address ni first node, which is si 10. Okay? Tapos, di ba, I've told you that node has two elements. Ang isa, 10. Ang isa data, ang isa link, tama? Or pointer. So this is the another node. So ito yung another node, another address or link that points to next node. So meaning to say, yung node na ito is held by this address. Okay? And yung node na ito is for now 5 yung hino-hold niya, but yung 5 natin as of this time wala muna siyang an address because it points to null and it points to nothing, and that's an indicator na oops, it is the end of the list anymore. Okay? So para mas masabtan, this is like ano natin, ilagyan natin ng \n like for a while. So yan, no? So first node is 10 and with the address which points to a next node 7 and the address, and then which points to the next node which points to null because again there's nothing after it. Okay? So yeah, although of course you don't have to do that kasi nga with the only thing we need to consider now are the data, not the address. But just in case no na you ever wonder, sabi mo sir dalawang elements ng node, may data and may address. So saan yung address? So that is what I have just shown to you na yun yung address ng isang node. Okay? So that's for traverse. Okay? So let's now have another operation. So public void add, let's say last. So add last na tayo. Okay na sa'yo, Gitigan? Sure ba? Nag-work siya kanina. Nag-work na sa'yo? Okay. At last tayo. So add at last. So iti-test din natin if empty. So if is empty, so tatawagin lang natin add at first or add first. Ganyan. Kasi nga empty. Pero pag hindi empty, yung gagawin natin dito is we're going to traverse the node. Okay, so i-traverse natin yung node through loops na din. Okay, so and gagawin natin is we're going to create an end of file loop here. Okay, so how do we do that? So we'll have first here node. Let's say link is equal to head, and then we'll have here while. A link, let's say that next is not equal to null. So ito yung the same idea here, no? Okay, so this loop right here, this guarantees that it traverses the end of the list. So meaning end node, no? Ang traverse niya dito is last node. Ang kukunin natin is the pointer of the last node. So now we have the pointer of the last node. So pointer of the last node. Okay, bakit kasi ganyan, sir? Kasi nga, yung pointer or yung node is every node in our list must be connected, must be linked together. Kasi if they're not linked together, I don't know how to actually, I could not imagine traversing our nodes if they are not connected with each other. Kasi nga, imagine if it's RAM is, yung RAM natin is may addresses siya, how are we going to traverse each of the address in our RAM? And we cannot actually do that. So whenever we create a list or a node in using linked list algorithm is we have to make sure that the lists are connected with each other so that whenever we do traversal, it would be easier to access it. Okay? Kasi kung hindi siya mag-create ng sarili niyang list, yung mangyayari is yung sa RAM natin o pag-traverse natin, baka we are going to traverse the things that we opened. Probably itong Eclipse, masasalin niya sa display. Yung if ever we open Microsoft Word, baka masali din niya display kasi it is stored to RAM. So that's why dapat intact yung list ng nodes sa ating linked list. Dapat they are connected and logically related and linked with each other. Okay? So, yun. End of while. So now, whenever ando na tayo sa last node and we get the address of the last node, so we're going to assign new node na naman. Okay? So gagawin natin dito is that yung new node will get the data through value. Yan. And then after which is since sa last year, gagawin natin ang next becomes now null. So it points to nothing or null. So again, indicator that nothing is nothing comes after it. Okay? It points to nothing. Okay? So now we'll make this node as the next node. Okay? So, di ba nakuha natin siya dito kanina? Ito yung pointer. So, yung pointer ng previous node will be now the address or the pointer na gagamitin natin for the new node. So, para may connection sila with each other. Kaya ito yung importance nito. Kasi ginamit natin siya dito. Okay? So this would mean that the pointer or the address of the last node will hold the new node. No, the newest node added or inserted. So yeah, okay. So end of here. So yeah, all right. If you are guys done, you can actually call it there sa to ang main. So let's say ll.add last, let's say 100. So you will see that 100 will be added at the last. Yan. So yes, it's actually yan. Ganyan lang siya, no? 50. So 50 will be added at the at first, and then 100 is still the last element or the last node rather. So I'll navigate from there to here para you will be able to see. So again, simple lang ang data structure kung built-in, no? Tama? Kung built-in, yung ginamit natin na list. Pero syempre, you are programmers in the making, kailangan you will know the hard way. You should have known the from scratch. Tama ba? Do you guys appreciate it? Na-appreciate nyo siya? Somewhat? Basta think of this way, na you can never be a technician if you haven't opened the what's inside of the parts of the computers. Tama? And you really have to understand what's inside of it. So it's the same idea sa ginawa natin ngayon is we are trying to open the linked list as to what is internally happens or as to how it is actually made up of or how it was made. Okay? So sige. So yung gagawin natin, gagawa tayo ng isang method, and then after which I will leave to you actually my mga tutorials ako with this one. I have created a video tutorial for this. So you can actually open it. Later, I'm gonna show you kung saan yun siya makita. And also my what you call this one? Yung activity nyo actually is also doing from scratch. No? Ipa-follow nyo lang yung instructions. Okay, so this is end of add last. Okay, sige. So now let's have the another method. So let's see, mag-remove tayo, no? So public void, let's say Ano yung sa linked list kanina? Remove ba yun? Remove last. Remove na lang. So remove at first. Or remove first ba yun? Parang remove first. Sige, remove first. So, dapat yung pinakauna yung ma-remove. Okay? So, syempre, if it is empty, end of remove first. So, if it's empty, we can have something here. List is empty. It's up to you what you want to do as a notification, giving the user whatever prompt, no? So, J option ba if you want the J option, you can use J option pane. So this time we're going to have here, node. Let's say link is equal to head, and then head is equal to link dot next. So para matanggal natin is we will assume the link is the head and then just replace with the new head with the next link. So yung the next node after head will replace as the new head. So as simple as this one lang. So that is remove first. What happens here is kung this one here, what happens here is that we assume na yung link natin is si head and then yung head natin will be i-replace natin with the next node after it. So probably mawawala lang yung previous head because it is replaced by new head which is yung node next after it. Okay, parang si 5 and 7, si 5 will be removed through replacing it with 7 as the next node. So tingnan natin if we are able to remove the node na first. So LL dot remove first. Then tawagin natin siya dito. So yeah, 50, 10, 7, 5, 100. So ito yung mga list nodes natin. And then by replacing the new head with 10, so yung yung next node ng head natin is 10. So si 50 is actually replaced by the new head which is now 10. Okay? So that's actually what you will do in the remove first. All right? So I guess that would be it. So ito yung again representation of the linked list. So I want you guys the other operations, I mean I will leave the other operations to you. So by the way, wait lang. While waiting, yes, Jemmy Lim, what is your question? So tingnan nyo ulit yung remove first. Ayan. And so we have here, Sige, my challenge now to you will be, try daw to create, remove first man ito, no? So, meron tayong add first, meron tayong add last, meron tayong remove first. Try to do it daw na mag-remove kayo last. Sige daw, on your own, while waiting. So, actually, there is the complete tutorial for this one with explanation. Andito siya sa video recording. Naka-hidden pa pala yung activity ninyo for this one. Yeah, so it's actually here. So my built-in linked list, explaining the built-in linked list, creating an empty node, add at first, tapos traversal with a little bit of figure and explanation, add at last, andyan na yan sila lahat. Okay? So, yeah. So basically, andyan sila lahat. Medyo lahi lang, ang iba lang din yung pagka-code niya. Okay? So the way I code here is parang it relates to the concept na term, no? Term concept. Doon sa ano naman sa video tutorial ko, maybe I use anything like pointer or PTR. Yes, there is a question. To clarify lang sir, dito po ba na statement mag-set ng address sa RAM? Head is equal to next is equal to null. That means po, Jemmy, na the head and the next is assumed to be null the very first time you create a list. So, every time mag-create ka ng list, null siya, meaning it does not have any address yet. But whenever mag-start ka na adding nodes, that's the time na may address na ina-set yung RAM natin, giving in or parang i-give out ni RAM to our to our program through compiler natin. Opo, okay. Sige. So yeah, can you guys try to remove nodes at last? So try natin if you're able to do remove last.